Transactions modes we presented, they are actually numerous, and specifically we present 4 modes. Most of them, the batch scope transaction and the non-batch scoped actually transactions. In the sense of batch scope transactions, they are actually to be mass transactions, means they are on top of multi-active result sets transactions, or let's say commands. We saw actually an example based on the .NET framework where we were able to see 2 commands passing in parallel within the same transaction, and the difficulty of controlling the uh, the mode of the transaction on top of those 2 commands. Uh, it is the reason behind of saying that it is a batch scope, and via which we are restricted from using save points across the transaction to control the commitment or the rollback of any of those 2. Means either to accept both or to deny both. So we are not able to make a time frame save points to control one of the commands. Here the example, and here we are seeing a non let's say non-mass based transaction, via which we are able to generate a time frame points. The save points here, those are time frames. This time frame here, it is to be utilized later on to let's say control the behavior of a full transaction. The transaction has started here. The transaction has started here as the beginning of the transaction here, and in between we are having a save point, a time frame point, time frame point. But we can actually utilize as a reference point, either to commit or to roll back. This actually can be done in a non-multi-active result set transaction, non-mass transaction. Why? Because such a type of transaction is a list of queries only, simple queries, simple SQL queries only: select, insert, update, alter, truncate, and so on. So thus, if we just cancel a query, it's okay. If we just roll back, we do not commit a query, it's okay, and so on. So technically, it is feasible. Technically, it is realizable. Technically, it does not represent any issue. It does not represent any difficulty here. So we can roll back. We can commit. We can actually a certain part, a certain block. Thus, this is the capability. And here we are not seeing. Here we are not seeing. Let's say we are seeing a batch scope, yes, but it is a non-mass based. Actually, we are able to use more than one commitment, let's say more than one mode within the same transaction, because the commit and the rollback is the mode. We are going to commit. Okay, this is a mode of the transaction. It has to be committed. We are going to cancel this rollback. So this is the mode also at the same time. So whether this or that, it is equal to the transaction itself. But in the case of the mass and the batch scope transaction, here we are talking about a nested transaction, maybe, yes, also. If you are having a begin inside a begin and so on, it is a matter of philosophy to understand it. But in all cases, we are not having commands that do have a standalone result to be considered from within the body of the transaction. How? And like in the example that comes after, here we are having a start of a transaction, we are having a beginning of a transaction. Actually, this transaction would start by creating a command, command number 1, and also it will actually generate the content of the command. And also the next slide, we are going to generate the second command, and this command actually would have its own queries. The transaction 1 would start, transaction 2 would start. The command 2 also will have its own content, and we are going to execute the command 1 and the command 2. Which one to roll back now? Because here the execution, the command 1 and execution the command 2 is completely irrelevant in time of in matter of time. It means we are not having command one first, command two first here. No, the command one content is a list of queries. Command two content is a list of queries. Yes, execution it is a sequence in time. Yes, here in chronological order, the command one will come here. But since we are using blocks with a scope, so we will be able to see that both of them, they are in the same scope. Both of them, they are belonging to the same try here. And we saw in the lab the context of the runtime errors and the exception handling. Here we are having a block that do executes the full block, either the full block to be executed or not. So both of them, they would be executed here. Either we execute the full block or not. So the context of the save points, it's not feasible to be utilized here. Technically, it will create a mess and it will not be actually accepted here. So this is a very clear multiple result sets that they are actually within the same transaction. So this is a mass transaction, and thus this is a batch scoped transaction. We have to commit at the end, or we have to roll back at the end. Very easy. So at the end, the transaction has to be committed, or let's say roll back. After the block of the try, we would actually call the catch block. Means the run time error. If happens here in this block here, that starts here and gets and here, either to be executed in runtime, or in case of exceptions, this block would be executed. This block would be fired, which is this exception here. Before of this try, we have the start of the transaction that has two commands. Transaction it is starting here. Tran. See the tran. This tran is a scale transaction beginning here. What are the commands? Command 1, command 2. Are you going to commit the tran with command 1 or the tran with the command 2? Are you going to roll back the tran with command 1 or roll back the tran with command 2? You cannot. Either you commit the tran, here it is, you commit the tran, or you roll back the tran. Very simple. Very simple. The tran has two commands. The CMD1 and the CMD2. You accept the tran, you commit it, or you roll back. You cannot control one only, one command from the same transaction, and you roll back the second command from the same tran. No. So this is a batch scope transaction. Why? Because it is having a more than one result set, which is more than one query, more than one command, and each command has more than one query. We come back to the beginning. Slide before. Command 1, the content of the command 1, it is a SQL command 1. The content of it is C. Here insert what? This first value, which is the select, the second value, the third value, all of them, they are sort of insert. So this is insert number 1. Insert what? Insert the row number 1, insert row number 2, insert row number 3, insert row number 4, and so on. So it's a list of queries. They are all in the same command. Command 2, where it is. Yes, here it is. No, this is the same. Here, command 2, here it is. Yes, here it is. It's SQL command also. We are having a query here. Only an update. It's okay, so whatever. So the start of the transaction would call both command 1 and command 2 to be linked to the same transaction variable. So the transaction here is tran, named tran, is user defined. So we are linking the CMD1 and CMD2. So we cannot separate them later on to have different save points for different purposes to control the CMD1 and CMD2? No, either you control both or not. So for this purpose only, for this exact point, any questions, please?
No.
Okay, let's pass to the isolation levels. Okay, the concern of the isolation levels here, what we are going to understand after talking about it's a chronological presentation, good presentation. After the modes, we talk about the isolation. What are the differences? The transaction modes actually either to commit or not within different perspectives, either to commit or not a full transaction or a partial portion of the transaction when we talk about the non-mass transactions. Yes or no? These are the modes. And the concern of the isolation, we take the example of the web-based transactions. Here, when we take the example of the EduWave, our University of Lisbon ERP, and we talk about the period of registration, that 2 days or that week of the registration period, where all students, all faculty, all staff, they visited the same resources from within the same from within the same system, EduWave. We face a big latency. The system is very slow. The problem here is not only that it is slow. The problem is that since all of the users, it's a huge number, there are thousands and thousands and thousands of users at the same time. The system might fail. Request number 1 will be swapped with request number 2. Resources number 1 will be exposed to all students or to all, let's say, other, let's say, users. So there will be mistakes from the system side. Those mistakes, they are technically described. Those mistakes, they are technically described. Described actually based on here we see they are we see actually there are 3 examples of issues technically described, which are describing the issues that might happen when the load of the system is heavy and the system is not able to manage all the requests or manage the live requests in general, all or live or both, all and live requests. Dirty red actually first issue, which is a concern via which a system makes a user see what other users has requested. Me, I open the student's profile or the student's registered the timetable, the registered courses, and he opens me another faculty, let's say students, not my students. I requested my students, he displays to me the students of another faculty. So this is a dirty red. The system caused a dirty red. This is an example only, an example only. The second issue via which we can see a system is running in a trouble is that the system, a user requests something and he receives something different. Yes, it is exactly similar to the dirty red, but this is because of the order of requests. Order of requests. So user number 1 requests file number 1, user number 2 requests file number 2, and then after user number 1 requests file number 2, which is requested by the user number 2, he displays to me user file number 1 from the beginning. He does not display to me the file number 2. He repeatedly displays to me what I requested. Something like that. So because of the order of requests in between the users, remember, we are not talking about 1 user, 2 users, we are talking about thousands and thousands of users. So non-repeatable red due to the order of requests to resources based on sessions. The system will make mistakes displaying the results. This is a non-repeatable red. The phantom, another issue that the let's say the live process, the system can cause due to the conjunction and the huge number of requests at the same time, is that the system, whenever it tries to retrieve data from a resource, once the same resource is being updated, the data inside the resource, the table, is being updated by another user, the system will not show the updates. He will show only the old data without the updates. This is a phantom red. This is a phantom red. This is another issue. It happens only on live processes, and it happens with big systems. And this is something that it has to be actually tackled. So we have to talk about the isolation levels. So we have to talk about the isolation levels. The transaction modes have shown us, all of us actually, that the size of complexity caused a problem in dealing with the transaction. When we saw the non-mass, we were able to generate the non-mass transactions, we were able to use the save points. But when we define the mass transactions, we are not able to use the save points. The same way here, the complexity causes a problem in executing a transaction. Conclusion to those issues here, those are issues only. Those are issues only. In live flow. Those issues here, do not expect actually you are using a simple system in local computer, for example, requesting to display list of users to make error. No, you will not see that. But you'll see it as per the example of the D-Wave and in a conjunction period of time. The D-Wave, there are thousands and thousands of users, and they use the same resources at the same time. So in this way, we may see the system making mistakes in displaying results. It is not because of the running of the system, no, but because of the size of the load. Dirty red, non-repeatable red, phantom red. Now you know what are they. And you know when they can happen. And you know why they might happen. What are they? When and why they might happen. Those questions, you have to know the answers now. You can answer them and you have to answer them. So, to solve those issues, you have to pass through. To solve those issues, you have to pass through a technical approach via which to avoid, not to rectify, to avoid. It's a primordial case. It's a primordial treatment. Means before the issue happens, you have to put the case. It's a prevention. It is not a remedial treatment. So those preventions, they are on top of tackling those issues one by one. I give 3 marks in the final exam if you repeat exactly what I talked about. What are the definitions I given related to the isolation levels? 3 درجات in the final. Can you do that, please? Immediately. Just you have a few seconds to do.
What, mister?
The definition related to what I defined to you. You have to redefine me clearly with examples. Classify. You represent the isolation levels. Isolation levels. What are they? What are they for? When we can see them? You give the example. 3 marks in the final. 3 marks in the final. Maryam.
Yes.
I need the definition.
Ready and committed.
Recommit. Recommit. What's the problem with the recommit?
Read
With the
commit.
red committed? What's the problem? Yeah, tell me. Full definition. Yeah, full. Yeah, define. We were talking about the isolation
This is
levels and
the
yeah, listening.
yes trans isolation level.
Yeah. So
Read and committed.
okay.
Read reblated. Read
Okay.
session isolated.
Mm-hmm.
This 5.
Actually, now I'm showing you a table with 6. Are you able to see my slide, Udaina?
Yes.
Yeah, great. Whatever. We're not counting here, actually. I'm not just limiting the number, but what we saw regarding the isolation level, we said that there is a solution to an issue that database-based projects face. The issues here, what we see, the dirty red, the non-repeatable red, the phantom red, actually those are cases that database-based project may face. And they might face not all the database-based project, but I'm giving you the example of the DUA, even the conjunction period during the registration period, where everybody they are using the DUA, and not only the DUA, they are using the same resources inside the data, the DUA, at the same time. The students' profiles, the students' transcripts, the majors, the courses, timetables, the same resources, they are being used at the same time by everybody, instructors, students, administrative people, all of. There are thousands and thousands and thousands of users at the same time. So we might have millions of requests to the same resource at the same time. Thus, this causes a problem. It's a load, it's a heavy load to the system. The system might file into an error of displaying results. The system run very fine, but because of the load, it might find in a technical error, and the groups of errors, they are classified into 3 groups here. We are seeing them in 3 groups, which are the dirty red. Through the dirty red, actually, you might see the requests actually being replied error in an errored way, because the system, instead of to display me, my students, for example, me, Murad, he displays, for example, Absattar students, another instructor or another faculty students, by mistake. Session, let's say, actually falsified. This is the system behavior. It's not an attack. It's not an attack. It's not an issue done by a hacker. No, but because of the system potential. Dirty red. Or we talk about the non-repeatable red, where also we see falsified results, but this is because of the chronological order of requests to the same resource. For example, student number 1, transcript. Due to the chronological transcript and another resource timetable or something like that. Chronological order of requests amongst of those same resources, the system might fail. Instead of displaying me what I requested, it displayed me what my other colleague, faculty requested. So, non-repeatable red. Another issue that the system might fail in, which is the phantom red. Again, also it's a falsified display. Example here, the system actually will not be able to display the updates done in lifetime by user number 2 or 3 or 5, while I'm requesting the same, let's say entity or data which is already updated. This is a phantom red. The system is not able to see the updates done by other users at the same time in lifetime because of the load only. So phantom red, phantom, ghost, cannot see actually clearly, something like that, technically, literally speaking. So those issues here, those 3 issues here, they are solved too. They are actually being faced to be solved, referring to the isolation level. One of them can solve For example, when you say the read and committed can solve all, let's say the commit here, they can solve the issues happening by the dirty read, the non-repeatable read, the phantom read, and so on. You might say, actually, okay, we follow this isolation level only. Okay, there are circumstances here. There are circumstances here because system, you are going to admit this isolation level for all the transactions. No, the isolation levels, they are actually to be defined. We are going to define them one by one because there is a time and there is a session control that has to be considered. Otherwise, the system will fail also if you admit one isolation level for all the transactions. No, you'll not succeed in delivering all the services. There will be limitations. The service delivery is a question. If you hear your name, just say yes. If you hear your name, I'll stop at this level. Later on, we will continue with the definition of those isolation levels only. If you hear your name, say yes for now. And we'll talk now just after about the in semester. I'm gonna give you the time to talk about the in semester only. Semester